Alrighty, class. Yes. So, let me see. Fatima, you're just seriously vibing there, aren't you? You got both earbuds in, music, you're dancing around. Not a care in the world that I'm trying to give you the answers to the test. No, exactly. Okay, please no. Alright. Okay. Alright, so I'm going to go through this. Now, the number one thing I've been preaching to you people every single time that we're doing one of these lessons, one of these things, one of these worksheets.
You can do it on your calculator.
Nope. What do I put on my paper? Formulas, right, Ethan? So what formula should I start with? Yep, the log one, which starts with log base b of. All right, so now what's the exponent version? Very good. So that's one of them. What's the other one? ln, right? ln of. And so what's the exponent version? E to the equals. Very good. So if you guys just start the test with this is going to help you with everything. You know how you actually like try and cram in some information at the last minute? Okay, then you're like, hurry up, give me the test. Okay, this is what you're going to write at the start of the test to help you with this. All right, it says the equation P of t is equal to 1 times e to the t represents population of bacteria in thousands t days after it was first counted. Here's a graph, y equals P of t. Now, what is the exact way to represent the number of days it takes the population to reach 100,000? Okay, so my initial population is what? One what? 1,000. So that's super important that this is 1,000. So every one represents, I'm going to write that right here. There is 1,000. Now, where would I find 100,000 on my graph? At the 100, right? Because this, every one of these is 1,000, isn't it? So I'm going to show that this one is also. There's my 100,000 right there. Now let's see. So if I'm going to use this equation right here, I need to set this equation to what value? Nope, not 100,000. 100. That's why I was starting with trying to explain what this is. Okay, right, Brooklyn? Because I know that phone's going away, right? Thank you. So I'm going to say 100 is going to be equal to my equation, which is 1 times e to the t. Now we're going to go through and solve, right? We're going to solve. You could actually solve for t by graphing it, but this one right here is actually pretty basic. So 1 times e is just e, right? Okay, so what would I do right here to get this by itself? I'd normally divide, right? 100 divided by 1 is still 100, right? So I'm going to disregard this 1 right here. And now we're going to use this. So to get that by itself, I'm going to ln both sides, right? Yes. Okay, so it's going to be ln of what? 100 equals, say it, t, right? T is my time, isn't it? All I did is I rewrote this. I used this to rewrite it because I had e to the t, right? Okay, and I just replaced this. Now, in my handy-dandy calculator, you're going to say what? What do we come up with? You know, you have this on, and I can't, yeah. It's like a want. Yeah?
4.17.
4.17, dude?
Do.
Due? 16 is due today. 17 is due tomorrow. All right. I thought you just called me dude.
Can we try this day even though it's tomorrow?
Yes. So, bringing up that calculator, because I know people are actually doing their work right now. Okay, not just staring at me awkwardly or waiting for Pacho to give you answers. Actually, having a calculator in your hand is super beneficial. Super beneficial. Not just regular beneficial, but is super beneficial. All right, so ln 100, I'm going to hit Control e to the x 100. So I'm going to say my answer is going to be 4.6. Now, you're going to tell me what it means, though. All right, what does t represent in this equation, Ethan? Say it. Days. So, it represents days, so it's going to be 4.6 days. Are we okay? So I'm hoping you guys follow along, because I see everyone just keep pulling out their phone.
Can't you just basically approximate the number from the graph?
You can, but what does this say?
Exact. So would bars be a good? No, bars wouldn't work in this situation. Or wouldn't it? If I were to plug in 1 plus e to t, and then
No, you wouldn't vars on this one.
no.
Mm-mm.
Okay, good.
Yeah, because if you notice, it's in the wrong format right here.
Right.
So you would vars this, okay, if you had this value here, because you're trying to solve for time, right? If I was solving for my population, I could vars on that one. Okay? All right, so use the graph to find a reasonable approximation of ln 150. Okay, so if I were to take this, and I'm going to rewrite this. Let's write this as an exponent because this is a graph of my exponent. So we're going to say my base is going to be e, right? The base is e to the, okay, to the t, right, is equal to 150. Okay, so now I'm looking at my graph. This is the graph of e to the t, right? So when does it reach 150?
5.0.
So for using the graph, we could just say it's 5. Yeah, but it's 5 what? 5 what? It says use the graph. I'm not going to get a 0.01 on that. 5
5.1.
days. There we go. I know, but I keep hearing people say 5.1, 5.01. I know, but it didn't say calculator. I said use the graph. Pardonnez-moi. All right. This next one says rewrite the original equation in terms of t. Okay? So the original equation, we're going to ln the original equation. We're going to have the original equation is going to look like this. It's going to look a whole lot like this, but now my x value x value, what am I plugging in here? Okay, this is going to be my y value, right? So if I'm rewriting it, it looks like this. So it's going to be, I'm going to write it down here. So it's e to the t is equal to my p, which I'm saying p is my population.
What was that? OP?
Population. So it is my population. So I'll rewrite it again. So P equals e to the t. Now, I'm just saying this is like this because I'm using P for population right here. So if I'm going to rewrite it in terms of t, I'm going to ln both sides.
Right.
So it's going to be the ln of my population is going to be equal to my time.
So both of those have to be put down, or only one?
No, just this one. Because it says rewrite it in terms of t. So in terms of t means that it's going to be t equals something. This one right here is going to be p equals something. So if I'm looking to solve for my population, I use this equation right here. If I'm looking to solve my time, I use this this graph right here, or this equation. Does that make sense? You just got to rewrite it. Like we were doing the other day on the notes, I changed this out so it will read easier because I have a population would be equal to e to the time. All right, so does a graph say, that 50 is a reasonable approximation for ln 3.8? Okay, well, let's see. Now, if I rewrite this as an exponent, my base is e. Like this. This is... Come on, brain, work. There we go. All right, equals t. So it says ln of 3.8 is equal to my t. Let's rewrite this as an exponent, so it's be e to the... Okay. So what is my t that they're saying to plug in here? 50 is equal to... Now, is that right? Is that close to right? No, it's not. E to the 50 is going to give you some huge number. So this one's not going to be right. If I rewrite these to make it look like this, you could actually see, all right, this one is not equal to 3.8, so you would say no, exclamation point. There we go. Ooh, man, someone's salty. All right, are we good here or no? Yeah, if you notice, I'm rewriting everything and then solving. I'm making sure everyone is basically rewritten in another it's either as the exponent or as the ln. So you have to be able to go back and forth in between those. Now, for this right here, it says solve each equation. So if you guys have been paying attention the last couple days, we've been doing a whole bunch of these. What would I try and do? I'm trying to get n by itself. What would I do first? Very good. Divide by 6. So I should have 5 to the n is equal to 125. Now, in this case right here, we are going to log this. We're actually going to log on all of them. So if I'm going to log this one right here, what's my base?
5.
Very good. So I'm going to write log base 5 of
125.
is equal to
3.
n. Okay, I got to set it equal to first because Jake Quillen, watch. See this next one? This next one's going to give you an issue if you don't write it out first. Okay, so now n is by itself, so what could I do there? Plug that in, please. Plug it in.
3.
Yep. So we should get, in this case, n is equal to 3. All right. Let's take a look at this next one. Same steps. So, what am I going to do to try and work on that? Divide by 4. Very good. 8 to the 3y is equal to 250. Okay, so what goes next? Log. So log base what? 8 to the? Nope. 250. Remember, I change these out. 250 equals. Now, is my y by itself yet? Nope. So I got to do what? There we go. So now the y is by itself. Now I could plug this in.
1.67
Oh, that's nuts. It's log 8, not 3. Where'd you get 3 from? You put log 3. What are you trying to tell me? It's log 8, right?
I'm already lost.
All right, so I get 0.89.
Yes.
There you go. All right, listen up. Same steps. I would like for you to try C right now on your own. Try C right now on your own. It's almost like you have a quiz that you have to do it all by yourself anyway. Might as well try it now.
What did you get 3?
Same steps. Do the same steps. Okay. You take this and your calculator for that too.
Pero me dices no. Remember when we heard that thing about
What else did you say? Okay, so I didn't do it wrong.
with AI the ghetto. Is this right? Are you supposed to have negative? Negative what? Where did you get negative 4?
Okay, yeah.
That's
Yeah, no, this is exactly.
Hey, can you check it?
We're at negative 2.41825.
All right, so, okay, I'm sorry I didn't make it around to everyone. Okay, divide both sides by 3. So over here, if I divide by 3, same as multiplying by 1 over 3, this will cancel and give me 1 over 256. So 4 to the x is equal to 1 over 256. All right, so now we're going to log both sides. Log base. Okay, log base 4 of 1 over 256 is equal to x. Okay, and so we should get x is equal to negative 4. All right, let's see.
Where'd you get 1 over 2?
We have 4, right?
Yeah.
And this is 1 over 256.
Yeah.
Okay, Lars, whatever you got. 256 first. 1 over 2.
So right here, see where I got right here? If I take this and divide it by 3, it's the same as multiplying by 1 over 3. And I'm showing that these will cancel, so it should be 1 over 256. Did I lose you on that? Okay, in your calculator, say 3 over 256, and then divide that by 3.
Oops. 9 over 256.
You multiply by 3. So, 3 over 256 divided by 3. Okay.
I did it I divided by 56, 256 and I got decimal and it gave me the same answer.
Okay, you use the decimals. It's fine. Okay, but yeah. You want to be exact in your answers. Okay. Yeah, you want to be exact in your answers though. Okay? All right, listen up here, please. Hey, I need your attention back up here. Okay, here's a graph covered by 2 different bacteria, H hours after they were first measured. What's the approximate coordinates of the point of intersection of the 2 graphs? What does it mean in terms of the bacteria population? See this right here? That's my intersection. Okay, so what am I going to say because of that? Okay, say it again.
4.9 hours. You would have the same population.
Yep. I don't think anyone has ever implied that you were. You're just very lazy.
Maybe I've been. I had a little mental breakdown. So it was like.
Yes, you did. It kind of sounded like that.
I said we all believe in you. I said we all believe in
It
you.
sounded like they all just.
All right, you guys ready?
Yeah.
Okay, so I finished this part right here. This was actually super basic. You just read the question and answer for what it means.
For your approximate assumption,
Yeah.
so that no one can really be wrong on that.
Bro, seriously, I wish I could say no one could be wrong. You should.
Okay, from the points 4.7 to 4.9, no one can be wrong on that, right?
Even if you said 5, I'll still take 5.
Oh.
If I said what it is.
Someone says 1.2.
Yeah, that's wrong. If you're telling me 6 point something, no. 4, I don't think so.
No.
But come on, there's a good range. Ah. All right, okay, going back to this. Okay, so the area. Okay, this wording is bad, so forgive me on this. Says the back area. Here's the area equation. Okay, and the population growth of the bacteria, the mold, right here, when this mold covers 2,000 square millimeters. Now, 2,000 square millimeters is a representation of what? Is that my area?
No. That's your, oh, that is your area.
That is the area. Square millimeters. So that would be the same as saying 2,000 m squared. Millimeter squared. That's an area. Square units are areas. Cube units are volume. So this is, again, this is an area problem. So it says, when will the mold cover this? So for this, I am asking when the area is going to equal this. So what am I solving for? Hours. I'm solving for the hours here. So I'm looking for the h. So that means I'm going to replace a of h with 2,000. Very good. So let's write that out. So 2,000 is equal to 20 times e to the 0.09h. Okay, so what do we got to do to solve for it? Divide by 20. So I should get 100 equals, very good. So at this point right now, what am I going to do? ln. So I'm going to ln both sides. So ln 100 is equal to 0.09h. Divide by what?
0.09.
Very good. Divide by 0.09. So h. So this is a point where we could put in the calculator now. So I got the h by itself. What do we get? Okay, so let's say, very good, 51.2. Now, in this context, what does that mean? Hours, very good. 51.2 hours for this mold, the bacteria in the mold, to actually equal 2,000 square millimeters. Okay, so let's take a look at this next one right here. The representation 1 times e to the 0.045 t models a balance in thousands of dollars where t represents time in years after the account was opened. What does the 0.045 represent in this context? Now, I need to rewrite this first using my formula. So, what does this one right here represent? Initial value, right? Yes, it is 1,000, right? But it's initial value. And what variable do we use for the initial value? Very good. So it's going to be P times E raised to the RT. Okay, this is my formula, right? This is the formula for this. Okay, this is the formula that we're using for this because that's where it gave us here. Now, if I'm looking in this format, what does this represent? So which is it? Is it the time? The rate. Because if you notice, I have this times t. T is still there, right? So it's not the time, it's the rate. So now my rate, that is, I'm going to write 0.045. Now, to try and get my answer on this one, let's write that as a fraction. And every time Ethan writes it as a fraction, he would put it over what? 100. I always want it over 100. When I write my fraction, we had an entire unit where we put it over 100 every time. So as a fraction, how would I write that? So what number goes on top? No, not all of this. Was it? 445? No. 145? No, not 145. Not 45. The reason why, if you guys take a look, it is going to be 4.5 because over 100, it's going to move my decimal over 2 spots. It's going to go 1, 2. So it puts us like this. Now, there's a reason why I do over 100 every time. Why do I do over 100 every time? I heard it. What'd you say? Percent, right? Do you guys remember the percent? The word percent means out of 100. The word percent means out of 100. So I would say that this is going to be 4.5% growth.
Wow.
All right, this next one right here says write an equation for the number of years in which it will take to be $45,000 in the account. Okay, I'm solving for t now, right? I'm solving for t, and so I want it to equal 45,000. So what am I going to write down first? Not 45,000. I'm not going to put 45,000 here. What am I going to write? Rafa, what am I writing here? And I know it has nothing to do with your cell phone. I'm not writing 45,000.
45.
Just 45. Why am I just putting 45? Each one of these represents 1,000, right? Good. So I'm going to put 45 here. Divide both sides by 1, right? So I should have 45 equals E 0.045t. What am I doing to both sides now? It's time to ln now. ln and to get the t by itself. Go ahead, put this in my calculator. $84 point what?
5.6.
Is it 5 or 6?
5. If you round it up, it's 6.
It's 6? Okay. And what does this represent, though? Years. Okay. Listen, you guys. I need you guys to make sure you guys are studying for this. Like, share, and subscribe. Hit that notification button.